Today we are going to be learning about the difference between pure substances and mixtures. Let's first look at the basics and general vocabulary you will need to know about the types of matter. We're going to start with an atom. An atom is the basic building block of all matter. This is my foundation or starting point. You can almost think of it as the ingredients of a recipe. It is the smallest particle of an element that still keeps the properties of that element. For example, let's say that this atom right here is an atom of copper. Each copper atom would have the properties of electrical and thermal conductivity, or the ability to tarnish. An element is a pure substance that is made up of only one kind of atom that cannot be broken down into simpler substances. You can have an element be only one atom, like copper, for example. Or you could have an element be more than one atom, such as a diatomic element made of two elements of the same kind. An example of this would be hydrogen. Hydrogen is naturally found as a diatomic element. Oxygen, fluorine, chlorine, nitrogen are some other diatomic elements. A compound is a pure substance that's made up of two or more different elements whose atoms are chemically bonded together. Each element has its own properties. For example, if I look at this compound here, we're going to say this is sodium and chlorine. Sodium is very reactive with water. It will explode if it is put in water. Chlorine is poisonous to our bodies. But when sodium and chlorine react to form sodium chloride, it makes something that is edible, which is table salt. So when you look at a compound, you look at how the properties of each individual element that makes those up are different when they are actually combined and bonded together. Another example of a compound would be water, which is two hydrogens combined chemically with an oxygen. An additional example would be an oxygen combined with a carbon, and that would be carbon monoxide. To show you the difference, this two hydrogen atoms together would not be a compound because I need to have two different elements combined together.
Okay, we already looked at atoms. Atoms are one building block. They're either, one green or one orange. But molecules are when we take two or more of these atoms and we start to chemically combine them together. They can be the same type or they can be different. In this case, we have two white ones. It could be two hydrogen, a diatomic element, hydrogen gas. Or we could have two red, two oxygen, another diatomic element, making oxygen, O2. Or we could have two or more together that are also different. These are compounds, both of them, but they're also molecules. In this case, they're molecules made up of, this one has 5 total atoms of 2 elements, the black and 4 of the white. This one we saw was water before. It's got 3 atoms, 2 of the hydrogen white and 1 of the oxygen red. All 4 of these are molecules. These happen to be the bonds with the same atom type. These are different. Okay, all matter can be described as either being a pure substance or a mixture. We're going to look at pure substances first, so we're going to get rid of this one. All pure substances are either an element, they're either a pure element or a pure compound. If we look over at the elements, we have the same atom type throughout. That means it's pure. There's nothing else in there. If we put them in a straight line, we can make them look like a wire. Maybe this green, it represents copper. If one little atom got in there, it wouldn't be pure anymore. So we need to get rid of this because all of them have to be, every particle has to be identical. Every atom is identical to each other. On the compound side, even though we have different types of elements that bond together here, we still have a pure substance because every particle looks identical to each of the other ones. And there's nothing else in here. We already knew that this was water, so in this case, every particle is the same, it's a pure substance. But imagine some copper got into here. Then it would not be pure anymore. We would have water with some copper mixed together. If we take the copper back out, we have purified the sample, and now this is pure water, and it is a compound, pure substance. Okay, we said that all matter is either a pure substance or it's a mixture. We said pure substances are either elements, where we have all the atoms are identical, like these green over here. Those, again, we said were copper. We could have an element that's this purple type. Maybe that represents something else like titanium. And we might have this orange element over here, could be sodium. Other pure substances are compounds. We looked at a couple of those in the last video. We can also put together some of these pure substances to make mixtures. Maybe we grab a couple of these green, and we could mix it with some of the orange element. If we put them all together, they're mixed. They're not chemically combined where we actually stick them together. They're not chemically combined. They just happen to be near each other. So we're going to pull them apart. And we call it a mixture because they're mixed together, but they're not actually connected to one another. This would be a mixture of different elements. I'm going to remove the orange. If I bring the water in, once again, we can mix these, but they do not chemically interact. They don't break apart and mix. They stay where they are. We can move them around, and this would be a mixture of an element, the green type, we said copper, and the compound of water, a mixture of an element and a compound together. If I take the green out and bring in these guys, once again, we have another mixture. They can move around and swoosh around, but they don't chemically interact. They stay apart. We have now two different types of compounds. We have the black with 4 whites. This could be something like methane gas, and this is water. They're not chemically connected. They're still separate from each other. It's a mixture of compounds. We could have a mixture of 3 different types of compounds with these. We could swoosh them around. They don't chemically interact, and we can easily separate them and pull them apart. Mixtures are very easy to separate. So this would be another mixture of compounds. We could bring in all the elements and now have one big mixture of elements and compounds, and we can very easily separate them back apart from one another and see each piece. So there are 3 types of mixtures. There are mixtures of elements, there are mixtures of elements and compounds, and there are also mixtures of different types of compounds.